we are going to start. We have quite a few participants online, I believe from all over the country and all over the world. So we appreciate you joining DTS this morning. My name is Steve Pruitt, and we're going to go over the Dynamic Data Recorder, or DDR, a new product from DTS. We always put this slide up to kind of remind people of how this works online. Some systems are set up differently. First of all, of course, check your audio settings. Hopefully you can hear me okay. And we like to use the question and answer box. So you'll see on your screen a little Q&A button. If you click that, you can type in a question. We will try to answer as many of those as we can real time. We will be recording this webinar so you can view it later. And also, everyone has a different application. I'm sure you'll have a lot of questions. Feel free to reach out to us after the webinar, and we can get into specifics of what you're looking for. All right, today your host for this webinar will be Kyvory Henderson. He's a systems application engineer at DTS. Myself, Steve Pruitt, I'll be one of the panelists here, hoping to answer some of your questions. Mike Beckage is the CTO of technical support here, also an owner. He's going to be trying to catch up on some of your questions as well. And so today, this webinar is really looking at data loggers. And DTS has been making data loggers since 1995, including 6 degree of freedom data loggers. They've evolved over the years. So we're going to give you just a short history of data loggers from DTS. And then we're going to dive into why the DDR, the Dynamic Data Recorder, and some of the applications that would work for you for this specific new smallest data recorder that we have. And with that, I'm going to go ahead and turn this over to Kyvory Henderson.
Thank you, Steve, for the intro. And thank you all for joining us today. And as Steve mentioned, we're first going to look at data loggers and kind of the history of data loggers here at DTS. So first, let's just start with that definition. So we define a data logger as a data acquisition system that's embedded with a group of sensors. In most cases, these devices are battery powered. They can capture multiple test events, which means the device can self-arm itself. In most cases, they're mobile, they're relatively durable, and they're easy to use. So one of our first data loggers here at DTS was the TSR Pro. And that was a 72 by 72 by 22 millimeter device with triaxial accelerometers that varied in range. It's around 237 grams of weight. The TSR Pro could record up to 2,000 events depending on your settings. You could continuously record for 34 hours. You could adjust your sampling rate between 1,000 and 20,000 samples per second. And that gave you about 3 months of battery life. And the TSR Pro was an IP67 device. As we kind of modified and developed this design, we upgraded to the TSR 60XP. As you can see, it's a little bit smaller. We broadened the range of the triaxial accelerometer, and we added a triax angular rate sensor with the 8,000 degree per second range, truly making this device a 6 degree of freedom device. We also added a pressure sensor, lowered the weight to 200 grams, kept the 2,000 events per device, along with the 34 hours of continuous recording, upped the sampling rate to 75 samples per second, bumped up the battery life to 6 months, and kept the IP67 rating. And then one of the more recent data loggers is the TSR 60XC, which is an 83 by 83 by 32 millimeter device or package size. We kept the 6 degree of freedom with the triax accelerometer and the triax angular rate sensor. Came in at a little heavier at 420 grams. Still 2,000 events, still 34 hours of continuous recording. And the main change with this device is that it's a CAN bus capable device. So that's kind of the history of the data logger here at DTS. And so now, why would you consider our newest device the Dynamic Data Recorder, or DDR?
Hello there, my name is Kyvory Henderson, and I'm a Systems Application Engineer here at DTS. And today, I'd like to introduce you to our newest product, the DDR. The DDR is a standalone shock and vibration recorder originally developed to be embedded in mouthpieces. The DDR is configured on a PCB flex circuit and can conform to virtually any surface. Bluetooth communications and wireless inductive charging makes this one of our most innovative products. Each DDR comes with a wireless inductive charging coil, a flash memory, magnet switch, light sensor, microprocessor, triaxial linear accelerometer, triaxial angular accelerometer, and battery. You'll need a charging case for your DDR units, which will allow for communication to a PC via USB, inductive charging between the charger and the DDR unit, and Bluetooth communication between the charger and DDR. Each of our DDRs is run through a rigorous calibration process on CAL machines that we designed in-house. This will make sure that you get the best sensitivity when it comes to your linear and angular accelerometers. Now, in order to set up your DDR, you'll need the DDR control software, which I have up for you here. And that will show you the serial number of the DDR that you are connected to, the charge capacity. Down here you can set and lock your time, which will be synced to whatever your PC time is. And if we collected any events on this device, they would show up here. You can also click through. I can see real-time data from my linear accelerometers and my angular accelerometers. Now let's go ahead and set this device up for our demo here. So I'm going to go up to initialize, and this new window that's popped up shows me my sampling rate, which is set at 5500 Hertz, my recording time, which I have at 100 milliseconds or 0.1 seconds, my pre-trigger samples, which I'm going to put at, let's just take 5 pre-trigger samples. My trigger threshold, so these are my linear accelerometers, and I'm okay with leaving them all at 5 Gs. My trigger window, which I'm going to set keep low here. My event capacity, so this is telling me that with the settings that I have so far, I'll be able to collect 207 events. My additional sensors, and it's an activity sensor and light sensor. I'm going to collect those. And my auxiliary trigger, which I'm not going to use. I also have the option here for session arming, which I am not going to enable. But this feature really tells the DDR that you want it to wake up at a certain date, at a certain time, and self-arm and stay armed for a preset amount of time. And during that arming state, it'll be looking for some trigger from one of your linear accelerometers. Okay, so I think we're good to go. I'm going to click OK. Now that you've set your DDR up via the DDR software, I'm going to run a quick demo here with one of our older calibration rigs, which will replicate a angular motion here and then a linear impact. Let's go ahead and put that there. All right, I'm going to pull it back. Release. Okay, let's check out that data in the software. Okay, now that we've run our demo, let's hook the DDR back up. and you'll see that 2 events have popped up here. So let's go ahead and download those. Okay, download complete. Let's click to review. Find those events. Let's go with this. You'll see here that our dominant axis was the y-axis on our linear accelerometer. I set the range to auto. If I wanted to filter the data, I could come up here and do that. I can zero the data as well. And that is a quick recap of our data that we've collected. Thank you.
DDR could also be used for monitoring head strikes while wearing construction PPE. Take it. Fits that curved surface. If you wanted to monitor heel strikes while a patient was wearing a boots perhaps, you could just take a DDR, slide it in there like that. There you go. And DDR is also flexible enough to fit inside of a pill bottle. If you ever wanted to track pharmaceutical manufacturing process, the DDR can be used for monitoring high asset value packages. Okay. So let's review some of the operation parameters of the DDR. And so the DDR can sample at 100 to 5,500 samples per second per channel. You can capture upwards of 350 events. The DDR includes a AA filter that is set at 1/4 of the sampling rate. There's Bluetooth communication between the DDR and the DDR charger. You can also wirelessly charge the device. And then your communications to your PC are via a USB cable that connects to the DDR-C or charger. All of your configuration is done via the DDR control software. There are linear accelerometer level triggers. As I mentioned in the video, we have session arming enabled on this device, which lets you set when and how long you want the device to arm for. You can filter your data for some light processing in the DDR control software. We can also export that data in Excel format. The battery that we've chosen for this device is a 27 milliamp hour nickel metal hydride secondary battery. If the device is active, you have about 8 hours of battery life. If the device is asleep, you have about 90 hours, and it takes roughly 6 hours to charge the device via the inductive charging coil. And the DDR comes with multiple sleep modes, which helps us manage some of the power. As far as sensors go, we have triaxial linear accelerometers with ranges that can go up to 200 Gs or 400 Gs. We also have our newest angular accelerometer, which has a range of 15,000 radians per second squared. On this device is also included a temperature sensor and a light and magnet switch for managing some of those sleep states. We have 8 megabits of non-volatile memory on the DDR, along with pre-triggered data buffers for the sensors. And what that really looks like when you collect data in your test environment, you can see in this table here. And what I'm saying is if you have a sampling rate of 100 samples per second, a 4-second event duration, you can collect about 250 events. If you bump that sampling rate up to 500 samples per second and a half-second event duration, you can go all the way up to 350 total events. And if your sampling rate's at 5,000 samples per second, you collect data for 0.1 second, you can grab about 200 events. Physical size-wise, the DDR is 100 by 9 by 4.5 millimeters in size. As you saw in the video, it's roughly 2 grams. IP67 compliant, and it's all manufactured on this new flex board. The DDR charger is 68 by 20 by 7 millimeters in size. It's around 9 grams in weight. And currently we're installing them in Pelican 1010 cases. So the DDR charger allows for you to communicate with your PC via a USB cable. It also is how the DDR is charged via the inductive wireless charging. And it allows for Bluetooth communication with your DDR. So a quick recap of the DDR. It's our 6-DOF shock and vibration data logger. There are 8 embedded sensors. You can sample at 100 to 5,500 samples per second per channel. It weighs about 2 grams. And you can record up to 350 test events. Again, just a recap of the software. You can set up your DDR and DDR control, which allows for you to set your clock, check your charge capacity, check the events that you've captured, while also setting your recording parameters, so your sampling rate, record time, your triggers, any additional sensors you want to capture, and then again, that session arming feature. You can view your data in real time, all 6 axes. And you can also review the events that you've captured and do some light filtering. The DDR goes through a rigorous calibration process where we set sensitivities on the angular and linear accelerometers here in-house. The entire sequence is automated. And of course, this is a NIST traceable reference sensor, and all calibration values are stored within the DDR. Okay, so for those of you that are still paying attention, I have a quick poll that I'll bring up here. So please, the question I'm going to ask is, what is the primary application you have used a data logger for? I'll launch that poll now. I'll give you all a couple seconds to answer that question. Okay. Got a lot of responses coming in. So far, sports and aerospace are winning the race. Okay, I want to end the poll now. And so our winner was aerospace. That came in at 22% of the applications that data loggers are used for. That's great. So let's just review some of the applications that may or may not have been covered in the video, just to give you all better ideas of how the DDR can be used and if it fits your test environment. So again, we talked about sports. We do have customers that embed the DDR board into mouthpieces for tracking head kinematics and looking for head impacts. But you could also take that flex board and to apply it to other sports equipment, including helmets. We have a couple customers that are using the DDR to track runners' heel impacts. So they're installing them in shoes, running shoes. You could also put a DDR inside of a boxing glove to look at accelerations there and to possibly check vibrational modes while biking. There are also military applications for the DDR. A couple users are looking at soldier fatigue during training, also installing them in some of the soldiers' equipment to look at accelerations. You could easily put a DDR on a helmet to look at head impacts, helmet kinematics, excuse me, and also into the PPE or boots of soldiers. DDR can fit a number of industrial applications. Due to its small size, you could install it or place it on a lot of industrial equipment. Again, to look at vibrational modes, check your manufacturing process, your QA process. And you could also put it, as you saw in the video, on some PPE for construction workers. And DDR can fit into a number of medical applications. With that IP67 rating, you could put a DDR in places where it might not be safe for other devices to go. You can also fit it and bend it into a pill bottle and check that QA process for your manufacturing. And for protective equipment, for people who are injured, you could put a DDR on a cast or a boot or perhaps a brace, maybe even crutches. So consider some of those applications as you prepare some of your research projects and your tests. And then in summary, today we looked at the data logger, the DTS, some of that size and weight that we've had in the past for some products, functionality of those products and their individual test environments. We went over why you should consider the DDR, brief introduction to the hardware, software, and how we calibrate these devices. And then lastly, we reviewed some additional applications for the DDR. As always, remember that you can bring your questions or concerns to the Help Center, which is found on our website. And then at this time, I'll take some questions. And of course, if you think of something after the fact or after this webinar, please reach out to me or anyone else here at DTS. Let's take a look at some of those questions. First question here, is the DDR available for purchase now? Yes, the DDR is available for purchase now. Of course, everyone's application is unique, so please reach out to us first and we can talk through that. Another question, would the dynamic bending of the circuit board hurt the device as long as it stays within an acceptable bend radius? So the circuit was designed to be bent, so as long as you don't bend it too far, the device should be just fine. Another question here, is the device watertight? And could it be submerged in water while functioning? So the PCB that we have here is conformal coated, but for full waterproof operations, we can add a secondary coat. Can you explain the accel sensing axis orientation? Is it along the length, orthogonal, into the strap, or along the short length? So each of the angular and linear accelerometers are triaxes, so all axes are sensed, true to the 6 degrees of freedom labeling. Here's a good question. Is it possible to attach external sensors? This is an integrated unit with no external sensor inputs. We have other products that take external sensors. We have a further development of this product in the works that will have external sensor inputs in addition to the integrated sensors. So that's coming. If this unit was glued in place, could you charge it on the unit under test? Yes, with the appropriate physical interface. You could easily put the DDR-C alongside the DDR-M. It's another good question. If one axis is overscale, does it affect the other axis signal level? No, there's no interference there. Here's another question about external sensors. Any timeline for an updated unit that would allow external sensors? And so yes, we have another data logger in the works that is more generic that's coming out in 2021. It'll be a little bit larger, but it'll have more of those external inputs functionality. Do you have a price for this device? Yes, we do. And I would contact us individually and we can discuss that. This is another really good question. SAE J211 recommends minimum 10,000 sampling rate. Is there a plan for a data logger that meets these requirements? The answer is yes. We're currently have some limits based on the technology, but we're working to support higher rates. The next version of the J211 will likely require 20,000 samples per second, so we're trying to stay ahead of that. Okay, I'm going to leave this page open as additional questions come in. Another question here. Are the accels AC or DC? That's a good question. All of the sensors for the DDR are DC. Another question here. Can you elaborate more on the Bluetooth data rates? Yes, so we can run real time at slow rates, i.e. 10 seconds of samples per second. And the Bluetooth interface is really intended for your setup and communication, and then download of your data. Okay, I'm going to give it a couple more minutes for any additional questions. Okay, here's a question. Is a user manual already available? Not currently, but reach out to us if you have any kind of specific questions or applications. Another question here. I cannot locate the DDR on your website or product guide. Can you point to the spec sheet? Yes, reach out to us and we can send you additional technical information. Another good question. Can we see the data in an Apple or Android mobile for quick check? Sorry, no, we cannot do that. This is a Windows only device. Okay, I have another question here. Can you display FFT in the software? Software is pretty simple and basic with data viewing after the test. So you would need to export that data in order to run any kind of FFT. Okay, additional question. Are there calibration requirements? So the DDR is calibrated by DTS versus NIST reference standards. And recalibration is also available here at DTS. And most of our customers will recalibrate once per year. Another question here. Do you plan to develop a longer recording time version at lower sampling rates? So yes, actually we are looking to add more memory to the device in 2021. Let's see, what is the bandwidth of the gyro and triax? The bandwidth is adjustable in the software up to 2500 hertz. Okay. I'm going to give ourselves another minute or so for additional questions. Again, if you think of anything after the fact, just reach out to me at my email address here. It's a comment here from a user. A very cool device. I look forward to talking about it more soon. I completely agree. I think it is a very cool device. Thank you. Another question here. Is this an 8-bit system? And it is a 12-bit ADC on all channels. Okay, I don't see any more questions pouring in here. So I am going to call it. Again, if you have any additional questions, feel free to reach out to me or anyone else here at DTS. And again, thank you all for taking time out of your day to join us. Thank you.